Okay, so question 1. The initial diameter for a cylindrical rod is given, and the question is about fatigue and its fatigue life. So maximum tensile and compressive loads are given, and the diameter is given for the material. Also, this SN curve below is given, stress amplitude versus cycles to failure. Now in fatigue, the stresses that we have, if we plot stress versus time, are cyclic. These can be compressive and tensile and compressive stresses. This is, the plus is tensile, the minus is compressive, or they can fluctuate between 0 and the tensile value, or they can fluctuate between two positive values. When the stresses are cyclic, we have what we call fatigue failure in the material. And after applying many cycles at a particular stress value, we obtain what we call S versus N curves. This S is the stress amplitude, and this N is cycles to failure. Now the amplitude is the difference, half of the difference between positive, the maximum of the cycle, and the negative of the cycle. So sigma amp, or S, is going to be sigma max minus sigma min divided by 2. And at a particular stress amplitude level, you test the material until failure, and you obtain your data points. Then you get what we call these SN curves. So for our material, we have these SN curves here. For 1045 steel, for aluminum alloy and red brass, the 1045 steel, as you see, shows a particular behavior known as endurance limit or fatigue limit. This behavior is particular to steels, unique to steels. So for the given diameter value of 8 millimeters and maximum and minimum loads of 7,500 newtons, we calculate maximum stress from P max over A and minimum stress from P min over A. The maximum load is 7,500, minimum load is minus 7,500, compressive and tensile. The cross-sectional area is pi d squared over 4, and if you calculate these maximum and minimum values, you will obtain 149.2 megapascals. Also for the minimum, minus 149.2 megapascals. The amplitude S is then going to be sigma max minus sigma min divided by 2, which is going to be 149.2 megapascals again. If you go back to the SN curve, 149 megapascals is somewhere around here, and the material is red brass. So we go to the curve of the red brass here. We are somewhere here for cycles to failure, and if we go down, we see that our cycles to failure NF is 10 to the power 5 cycles for this given amplitude.